and hot and humid. That might be on the outside of it. Um, I don't know. Um, uh, uh, yeah, it's another talk, but uh, the point here is that whether it's inside, as we see in this larger building, or it's going on the outside of the structure, it's a system, and there are going to be a number of parts and pieces, um, and it's at the connections of one piece to another piece, the window frame installations, the wall to the roof. How are we going around this floor construction, where we want to make sure we have robust connections, and whether the building's a single family or a bigger building, you're looking at all those points and identifying them and making sure that the details are delivering it. Inboard is the priority, and so double stud wall. This would be nice if it had a service cavity, but it doesn't here. Where this is very typical construction, where we have a 2x stud wall, and let's just put all the insulation outside and around it. And this sheathing can be the air barrier, or we may have a peel and stick WRB over it and be the air barrier. Pretty, tweaking conventional construction with a rain screen on it. Mass timber with the face of the mass timber being the air barrier, insulation and rain screen, and so forth. Similarly, in commercial construction, we can use the metal stud. We'll talk about this, how it compromises the insulation layer and what we need to do about that. But very straightforward in terms of having the air barrier there, inboard of the primary insulation layer. So vapor control. One thing I like to say is pretty much universally, like, forget about vapor barriers. Do not describe materials as vapor barriers. The one place we'll have a vapor barrier is to the ground, typically. So you'll have plastic sheathing. It's going to be a water vapor barrier and an airtight layer to boot. For the walls and the roofs, as much as possible, we're going to look to be relatively vapor open. We want the building enclosure to be able to dry out. Things can get wet, as we described before. It needs to be able to dry out. It's the moisture getting trapped in the enclosure where the damages really come. They will only dry through vapor diffusion at that point. And so we want to enable that. A key aspect, just in the way to frame it, is that we want the drying capacity to be greater than the moisture stress that's placed on the enclosure. Now, it's a little bit abstract, but we can think about it in terms of the parts and pieces that we're pulling together. We're not going to go through like WFI here or anything in terms of doing hygroscopic modeling and whatnot. A lot of the typical details can be, especially in your climate, be well understood to be robust. We need to, from the basic kit of parts, you can establish this formula, and where there are questions, you may want or need to have a more specific calculation done. Let's see. So, unless you were talking about the ground, we don't want vapor barriers. There's going to be glass in the windows, and there will be metals and whatnot, but we really want to avoid all of this in the wall and roof construction. There may be vapor retarders. We need to be careful about that. And in tougher climates, more careful about that. If you have vinyl wall coverings, could be substantial vapor retarders and trap. If you have a vinyl wall covering on an exterior wall, I've seen it all over the place where it traps moisture. If you peel back that vinyl wall covering, you can have mold behind it. The foam insulations will become vapor retarders and vapor barriers depending on the makeup. So we're always pushing towards more vapor open, semi-permeable, and permeable materials. Again, we want to shed the bulk water. We're minimizing the wetting. We want to allow the drying. And one of the things that's tricky, like I guess if you're up in the mountains, you'll have this. I know we have it in the Northeast, is like in the winter, the vapor drive is going out. But in the summer, the vapor drive is going in. And it's like, well, how do we deal with that? And one of the things, is to just let the vapor move through the construction and say that it will dry out. And depending on how harsh the climate is, then you may introduce vapor variable products that inhibit wetting in the wintertime. So it's retarding the vapor, and on the exterior side, it's vapor open. On the summertime, we may want to have vapor retarding on the outside. So in a hot, humid climate, we're looking to vapor retarding on the exterior. In a cold climate, we are looking to it on the interior. In your climate, it's pretty easy. It could be just open for sure. But what we tend to find is that the air tightness materials can also be the vapor control materials. And what we wanted then is the buildup of the assembly to not get in the way of that drying potential. Again, reason for the back vented rain screen. The service cavity will help with that as well to ensure it. Insulations. We can use any type of insulation in passive house. When we're looking at the drying potential of insulation, the fibrous insulations are definitely much more helpful. The natural fibers like dense packed cellulose and wood fiber are probably the most robust in that they can take the moisture, hold it, and actually move it to drier locations and increase the drying potential of the enclosure. So you may think of the cellulose as a potential liability in terms of moisture, but it adds quite a lot of resilience. We can't dunk it in water. It can't sit in a puddle, but the normal moisture flows or a minor leak, even if as long as you get to the leak, it will dry itself out, assuming nothing else is getting in its way. Mineral wool is great for allowing vapor and moisture to dry out through it. It's not engaging the moisture in the same way as rocks, as it's not engaging it in the same way as the natural fibers. Similarly with the fiberglass is good. The foam is hydrophobic. You can use them. There's no inherent problem with them. You just need to be more careful and know what you've got. And you may be in a position then to need to do a woofy model to understand what's happening. But then again, there are buildups well known around that. This chart is like too much, but I think it's good for reference as we're looking at the different climate zones. We're looking at variable inboard vapor control in a cold climate and open outboard. In a cold and warm, humid climate, it's variable. Open and hot and humid, and open and dry. Fibrous insulation across the board, and really where it switches is in the hot and humid outboard control, vapor control. We want to have it retarding. So we're not getting the exterior humidity into the enclosure and into presumably cooler interior spaces where you could have condensation issues. On the roofs, you're going to be able to, you know, do the insulation just within the cavity. It's always better to have a continuous, purely continuous insulation, and where we can do it, we want to do that above the roof rafters. We want to have a service cavity below the interior air barrier. We do want at the roof an interior air barrier. We don't want to rely on the roof deck. If we're going to rely on the roof deck, we want to have insulation above it sufficient to know that it's going to stay warm. Again, you're in a forgiving climate, but still these are basic approaches. A cold roof is a great way to do it. So you have the basic enclosure with the membrane on the roof, and then you have furring on top of the roof deck. I don't have a diagram of that for some reason. And this detail sort of shows it. You've got furring coming down here. You can see the furring strips at the end there. And then they're applying another plywood roof deck and the roofing on that. So that cold roof is a back ventilated roof, like a rain screen on the wall. It's applied to the roof, and it's kind of like flipping that perfect wall around. The Building Science Corporation perfect roof is the straight up sort of commercial construction where you've got the water barrier insulation and ballast. Thermal control. The insulations, again, I don't need to really go into this. I will say we're developing standard and manufacturer specific across a wide range guide to conductivity values to use in Passive House for simplifying kind of initial calculations and hopefully making that more robust going forward. The big idea here is that, and one of the great reasons to use wood construction is that the framing, where we have insulation in framing cavities, the framing can play a big role. Where we see on the left, the nominal value, R value of the insulation is 22.3, the actual R value is 19. So we've taken a little bit of a hit there. On the steel stud wall, we're cutting it in half. We still see examples where people are insulating metal steel stud cavities because they need that little bit more of R value, and it's okay to cut it in half. It'll give them enough because for one reason or another, it's easier than just putting it outboard. I mean, why not get rid of this insulation and just get the full value outboard and do half the insulation? It's really undermining it. And it's one of the big problems, we have with larger scale construction, rain screen construction, where the typical clips and Z-girts are undermining the performance of the enclosure. And so in a Passive House, we are really looking at these. And this is a great study by Stephen Winter Associates, done many larger buildings, looking at standard products for girts, for clips, and showing that the thermal efficiency is half using these. It's cutting the thermal qualities as much as in half. It's making the insulation a sieve, whereas we can change the materials, change the sourcing, and maintain the vast majority of that insulation value. So just the specification is going to be super important. And it's great. There are more and more options out there. So similarly for the clips, you see the typical, like down at a 50% loss, and we can do much better. And then it's different if you're on a steel backup or CMU backup. This is obviously looking at commercial construction here, but I think we can apply that to residential as well. Uh, Brick veneer ties, similar story, although these are better for the standard product. We can do better. And for the angles, we can do much better as well. So, these things in terms of thermal control, it's the thermal bridges at all these connections that's undermining it. It can account for 20 to 30% of the heat loss. And it's why mechanical engineers oversize mechanical systems, or one of the reasons why they quote unquote oversize them is because they don't believe that the building is going to perform, right? Nobody has confidence that all the detailing is there and they have control of the environment. They need to allow, sort of CYA to cover bigger swings in terms of what might be possible. We're looking to, throughout the design process, identify all of these locations of potential thermal bridges and put in conservative placeholders in schematic design. We're doing an energy model in schematic design and running it and seeing like where the overall numbers are, where our energy budget is, and then start to dial it in. And we start to dial in the the details at these potential thermal bridges in DDs and CDs for sure. And we want to leave a buffer. And it's really, it's at these corners where you've got three exterior surfaces, in this case, coming together. This is, where you're going to have your biggest problems. And if we can solve these problems, like at the window installs, we're going to have a really robust enclosure. Some examples of different breaks. There are fabulous structural breaks now, going from inside to outside and balcony connectors and awning, canopy, cantilevers, and all the rest of it. No gaps, talked about that. Prevent wetting. Help the drawing. So let's talk a little bit about just efficient design and how Passive House makes us think about it. And you can have a really complicated and much more complicated than this volume. And when you're in easier climates, it can be more complicated. And so I keep saying enviously, in your relatively easy climate, you can be a lot more adventurous in terms of the forms that you're using, and not pay that big a penalty. But it's really important to note that as you are adding complexity to the thermal enclosure, the surface area of the volume, you're adding to the energy budget and you are adding to the need for insulation and being more robust in different ways. A key aspect, as we say, articulate the skin and not the thermal enclosure. So like there's one is not like the others. The Palladio Villa in Villa Rotonda in Italy, in the upper left, is as close to a cube as we're going to see, and for many buildings and classical buildings, but it's still the skin is highly articulated, principally with the porticos. And we see that with a number of different building types here. Well, these are multifamily, but ways of doing that. And, it's finding that synthesis of beautiful form and simplicity and performance. What's inside and outside in the sense that you need to have really clear, and this is a big building, but it's true for any building. Um, what is the thermal boundary? And so in this building, we're not as worried about this joint here, right? This isn't the thermal boundary to our passive house. This one, though, is really important. This is super important. Um, and having control of that is really, really important. Um, the efficient form, sometimes, especially when you're on a passive house consultant or designer, you may be given a design and they may not have optimized it. You may not have a lot of control. And that can make the project more expensive and more technically difficult to execute. But if you're able to start at the beginning of the project and work through it, to the extent that you can make choices that make the form more efficient, so it's less this and more this, it's going to be easier. You can make this a passive house. There's no prohibition against it. It's just not going to be as easy. You can do a balcony that's inset, and there are lots of passive houses that do have these balconies insets, but one that is set out here is much simpler in terms of dealing with the thermal bridge and dealing with uh, the control layers, the constructability, all of it is more straightforward. Just a quick note, advanced framing, some are this more and more integrated into construction. I don't know if it's business as usual, but certainly we are seeing folks that are going into passive house often are already doing incorporating advanced framing where they just have less framing, and to the extent that we can have those corners and those connections, all to the better. A few more aspects here. So we talked about the shading before with the windows, and I think passive house makes us want to incorporate shading into the architecture in a way that conventional building hasn't done over the last any number of decades, post World War II. It's kind of, gone to, oh, well, we'll have window blinds on the inside. But if we look at the homes that were done pre-World War II, if we look at the arts and crafts homes, even the Spanish colonial homes per se, with heavier mass construction, um, you see the use of shading. They didn't have air conditioning, and we want to bring that back to uh, the fundamentals of the architecture and the performance that it brings. And I think it can add a richness to the architectural expression. We want to kill bad balconies. Balconies are something that's always added, people need to have a balcony. But the problem is they're often not deep enough. They're not big enough to actually use. And they often end up, and this is a worst case scenario to be sure, but they end up to just be an exterior storage space. And what we're saying when we're looking at the enclosure, the balconies are a big deal. We need to deal with a whole bunch of issues in terms of thermal bridging and structure and performance with the envelope. Like, let's make sure they're really good balconies that people are going to want to use, or let's not do them at all. Windows are really interesting in that, people think, oh, you're going to have tiny windows, or you're not going to have daylight, or you're not going to have views, or you can't open them. All of these things are not true with passive house. Passive house is absolutely about bringing in daylight and views and connection and natural ventilation when you'd like it. The key thing we want to say is that the windows really need to have a purpose. We're not typically just wrapping the building in glass because we know from a comfort perspective, performance perspective, it's really bad for the occupants. There's glare, there's overheating, there's discomfort. And so, Passive House asks us to really consider it. You can do a building wrapped in glass, and there are Passive House buildings wrapped in glass. It's not the cheapest way to go, obviously, and you need to do a lot to mitigate that. Um, but uh, but um, uh, we can do this. And so the key thing when we dig further into the windows is, again, this idea of simplification and what can we do to make things easier or harder. In a window, in a Passive House window, the frame is the worst performing part of the window, right? And so if you have a bunch of small windows, you have a lot of frame in proportion to the benefit you're getting from the glazing. And so it's a relatively poor performing window. As you go to bigger windows, they perform better. And so if you have fewer but bigger windows, you're going to have a strategy for having a higher performance enclosure rather than many smaller windows. You're also going to have fewer openings to have to deal with. And then if you have a large opening, we typically don't want to then subdivide that 100 times. You can do this in a Passive House, and there are many Passive Houses that do this. But these frame divisions are really degrading the performance of the window. And uh, and so you're adding cost and complexity and lowering the performance. So it's really asking you to strike a better balance. And again, there are all kinds of windows that are a lot of yeses here. These are certified windows that are provided, and then windows that aren't necessarily certified. This is the type of information you get with the certification of a window. So you go into their database and look it up, what climate it's appropriate for, and you get different values for installation and different configurations. There's more pages than what I'm showing here. A lot of great information, and it does come right into the PHPP. I'll say also repeat what works is a mantra. And this is, no magic here. And architects and builders like to repeat details and components that work. And it's really important that we, in the Passive House world, do this with vigor as well and make it as simple as possible. So let's look at some details. There's some more comments here. How important is it to do a dew point analysis when locating the vapor air barrier? I'm confused. The vapor barrier is on the outside and the air barrier on the inside. How does the location of the dew point change? Hot, cold, warm, humid zone. So no vapor barrier on the outside, we'll say, Francis. And the air barrier ideally on the inside. So your WRB is going to be vapor open or vapor permeable or slightly resisting, but it's going to still allow drying outward. It's going to be waterproof. So something can be waterproof and vapor open. It can be airtight, waterproof, and vapor open. There are all kinds of materials available today to do those things. Essentially, though, where you have a relatively moderate climate and you don't have vapor barriers or seriously vapor resistant materials, the air barrier could be pretty much anywhere. We want the air barrier inboard of the primary insulation layer. However, just to keep the conditions conditioned air in the conditioned space. If your air barrier is outboard of the insulation, your conditioned air is always going out to that air barrier, and it's filling, it's going to be heating or cooling the insulation, which is preventing, is a thermal barrier, but we want to maintain that control. So having the air barrier inboard, it can have vapor permeability. Uh, uh, will typically maintain a safe construction. Let's look at some of the details, and I think we may be able to come back to that, and I can follow up on some examples. So I think it's important to say that, well, passive house is kind of new in that, it's kind of a thing. Again, it's basic building science rigorously applied, and so we're just using the same old building science. Maybe there's some new insights, but there's a lot of things that have been done. You don't need to reinvent the wheel. You don't need to come with a breakthrough of how to do something. Don't start with a blank sheet of paper. We can keep it simple. We can learn from experience. This is the first modern passive house. It was built as a science experiment in Darmstadt, Germany. And you have a masonry construction. You have the foam insulation outboard of it and stucco insulation. So you can see the masonry, the foam, and then they stuccoed over that. And it's pretty simple. They had to customize the windows, they had to customize the ventilation system. The air barrier was on the inboard of the structure, is the stucco finish on the inboard. So it is not typical of what we would be using here, and we can't copy this, but there is a lineage of things. There's a lineage from North America in terms of the persist and remote systems. So we have a disengaged rain screen facade with the brick here, a gap, the insulation, and without insulation or with insulation. Totally valid. And in harsher climate, the remote, where all the insulation is going outboard of this primary air barrier here, and the studs, again, are just the service cavity at that point. So we can beat the hell out of this interior surface, and we're not disturbing the control layers at all. And then this is a back vented rain screen, although it's not drawn, it's not so clearly drawn that way. What they're missing here, though, of course, is, well, how are they carrying through here to be really as rigorous as they are with the wall? And what's happening, at the floor as well. Double envelope was developed during the oil crisis, which we call the double stud construction. And so these things have been around quite a long time at this point, and we are definitely building and refining just what they have done. A lot of the really accessible refinements we can find on our manufacturer's directory in these under enclosure systems. And so here's a whole bunch of companies that make panelized construction. And here's one company and their set of basic details for a project. And you have the basic components in how they're coming together. And it's really interesting. It's kind of a variation on what we've been talking about. This is the structure. This is like the plan view of a corner, which is a stud construction. Here's stud construction on a platform framing, and then another stud here. but they're using I-joist outriggers, so they need a really thick parka here. They can't just use the stud construction. In your area, you can literally just turn this stud construction into the insulation layer. But they're using I-joists to create a big puffy parka. And so these companies all have systems worked out, and the ones with yeses have them certified by the Institute, and a whole lot of information about their performance, their connections, and what's possible. I definitely encourage you all to take a look at the resources that these companies have out there. We see things going panelized. There's certainly these details can be applied to site construction, and we see amazing site construction happen, but we're seeing more and more of a combination of bringing the panels of the core components together with the site finishing. Yeah, and so let's look at some examples from some of these resources. And you can go back again. We have links to all of this. And you'll see that it's kind of repetitive in a way. So this is a mass timber building. And in this, we have the air barrier on the exterior face of the mass timber construction with the insulation outboard of it. And then we have an air barrier drainage surface on the face of the insulation, water control, and a back vented rain screen. And then we kind of have variations on that around the enclosure. And you can see very diagrammatically, but it connecting to the window and so forth. 475 has similar details and drawings and whatnot for a variety of construction types. It could be retrofits, it could be 2x wood framing, double stud, I-joist outrigger. Oftentimes, it could be some variation on a 2x wall construction. Here, it's just showing insulated cavity with sheathing, membrane, and then continuous insulation and a back vented rain screen. On the inside of the stud, you've got an air barrier, service cavity, and gypboard. So this is kind of a typical buildup. On the Rockwool guide is wonderful. It's slightly different construction types, but these are transferable too, I think, showing really kind of clearly the approach to having that continuity. So on masonry construction, mineral wool, of course, because that's rock wool, with a back vented rain screen construction. Interestingly, the 3 blocks we've got here are going to be aerated autoclave concrete, which have a better thermal value. And so we're minimizing any thermal bypass at the corner. Essentially, a similar thing: structure, insulation, airtightness, waterproofing on the exterior face, insulation, rain screen, structure, service cavity, finish. The windows really haven't explicitly gone into this, but the placement of the window in the line of the insulation is preferred, ideal, gives the greatest continuity. If we have that window shifting away from the insulation, it could be going through, and this is a great illustration of proper configuration. There is blocking around here, and so this is less than ideal. Usually at the sills of a window is the toughest part to have really good thermal quality. And so this joint is usually that weakest link is where we're looking at that and where we may do a thermal bridge analysis and zero in on it. But the components are quite normal in a way. The steel studs, we've talked about this a little bit, where we've got a service cavity, we've got them using the insulation in the studs. They're going to get half the value, but it gets them over the top because maybe going too much deeper at the exterior was going to be onerous. And it was easier just to take the hit on the inside. And then the back vented rain screen on slab and a flat commercial roof. What else do we have here? Steel at interior bearing walls coming through, how we're dealing with that around perimeter. I-joist. Steel construction is a kind of a whole other animal, and we're not really geared to do that here. But I did want to show these so you'd have them for reference and know about the reference and be able to come back to them. This great brochure by well, it's more than a brochure, a guidance from the Passive House Trust, the Passive House Association in the United Kingdom, led by Archetype in producing this. And it was based off of a school that they did in Scotland, really looking at all the different configurations and issues and working them through. So it's not like we don't have to do wood construction. This is possible. It does require a bit more thought. We can do SIPs. SIP construction here, and I apologize for the quality of this bit. But we basically, have a traditional SIP construction, but it's attached like panels to the 2x construction. So maybe it's not typical SIP. And it's basically one big insulated sandwich panel going around, applied to the 2x, and then getting picked up the truss at the top here, back vented rain screen, and foam SIP construction. You guys will not need this, but it's a really neat innovation. It's kind of like, I don't know if it's not really, I wouldn't call it the poor man's I-joist outrigger construction, but it's kind of one of those do it yourselves sort of thing. So you need a deep cavity, so you're up in a tougher climate, and you can see a lot of the common elements. They've got the frame construction. They're going to have sheathing here. They're going to have the air barrier here. And so this is the conditioned space here. Outboard of it and I think it's better to see here. This OSB is that sheathing on the wood frame construction, but then this parka, rather than using I-joists as ribbing, they're using little outrigger pieces of wood made to framing that carries it in a very light way. And you can get very deep construction with very little structural material. Yeah, I'm not sure. Well, I'll come back around. Insulated concrete forms is also possible. Straightforward. Again, this is in a northern climate. You're not looking at this much insulation. But if you have somebody in there like, well, we do insulated concrete forms, this is what we do, this is what we want. It's like, yeah, no problem. You can do that. The details exist. These project details are in the database online from the Passive House Institute. And, it's always coming down to these connections. This is really nice in that the insulation is overlapping the frame. So we said the frame is the weakest point of the window. We want to minimize the exposure of the frame. The glass is good, and the glass is getting better. And I see Chris here noting that glass is getting even better. We like that. The frame is the tough nut to crack, to be sure, and those are getting better too, but everything we can do to minimize it, the better. So having that insulation come over the face of the frame where the distance between the insulation and the glass is minimized is way higher performance and huge benefit to the overall energy balance and resilience of the building. Couple of just final thoughts here on this. In execution, we can do site-built passive house. It's great, and a lot of great contractors doing great things. This is not a plug, but Danica and I, before we started this conversation, we were just waxing about how much we loved Mike Horgan, and the work that he does out of San Luis Obispo, and there are a lot of great contractors there, and there are a lot of great contractors up and down the coast in California and across the US. They're really capable of doing this stuff. And we love to see them take it on because they're made for it and they can really make it work, and whether it's small or large. We see the panelized systems coming on strong though, and I think the industry is definitely seems to be moving this way. I can't predict the future, but in terms of mass production, in terms of scaling, in terms of quality control, in terms of ultimately affordability, I don't think this is necessarily the most affordable way to go yet, but it is, if it's not the cheapest, it is an affordable way to really get high performance and have a lot of control, and things like schedule and things like, knowing what you're getting is amazing. And I think that's only going to improve. And that's going across the country. So yeah, there we go. So to repeat myself too much here, but it's about the systems, and you don't need to use these systems. You don't need to use passive house components. It just, these different aspects make things easier. And I would say at the very least, you want to dive into the different components and dive into the different systems to just learn from them and the different projects that you're going to see, and encourage you to visit passive house construction or finished projects whenever you can. I know it doesn't happen often, but we like it when it does. We've got these resources again. These are links to many, many things. It's not everything that was in the presentation, but most everything. So if you can't find it, obviously Googling something's easy enough, but many links there, and we'll share the PDF for sure. So that, no, I didn't see any further questions for me to answer. Did folks have in particular questions, Javier?
Yeah, so my question is, I ran into homes where the attic, the ceiling is insulated, the knee walls are insulated, and then the under the roof deck, it's also insulated. Okay, but then they vent the attic. And to me, it's like, it doesn't make any sense to insulate all that stuff and then put a couple holes up on the roof.
Yeah. Yeah, what you want is to either make that attic air part of the airtight enclosure and you want to make it really airtight. Um uh and so you bring that attic into the thermal enclosure. Um because that insulation right on the roof is not doing anything.
Yeah, and I see it on the design, blueprints and on the requirement, the Hearst Rater certification, and it's like,
Really?
well, it's here, but why are they venting the attic? It's like it just didn't make any sense to me. But it's like maybe you knew something that I didn't.
Yeah, no, I think that you're absolutely right. No, from everything that you've said, your conclusion sounds absolutely right. What I would say is like get rid of the insulation at the ceiling, put the insulation in the roof rafters. So it's a drop ceiling, like there's a pitched ceiling above a pitched roof above the ceiling of the space, right?
Yeah, it's a normal. I mean, you can get in there and walk
Yeah,
around, and, kind of
yeah,
touch down, and then, but all of a sudden you see,
right.
well, why are the vents there if
Right.
you
Well, and so this is another argument for the fire, I think, resilience of it is to not have a vented attic, to to not have another way for embers to be able to get into your building.
yeah,
So, and in that case, don't insulate, if your attic isn't vented, it needs to be in the thermal enclosure. And so having the insulation at the ceiling of the space doesn't do you any good. Put the insulation in the roof structure, and then you have you can, I mean, you can have sheathing and then uh, uh, um, put insulation. You could have insulation outboard on the roof structure as well,
yeah.
continuous, which I know is part of well, I don't know what's happening with the California code now. Did they got rid of the update, didn't they?
I think
The
it's just the design that, they put it on there, and it kind of, I don't know if it's a default, but it goes and then the builder does it. But I don't think he understands why he's putting it up in there. So
yeah,
anyway,
yeah, I think
thank you.
conceptually the roof's either, the space is either in or out. And if it's out, that
Yeah,
insulation on the roof is doing nothing.
yeah. All right, that's what I thought. All right, thank you.
Yeah, thank you. Anything else specific like that?
Yeah, we have some comments on the chat that it's Finley Verity said probably the high performance attics in the California building code. And Patty Kloss also said it's code requirement to vent an attic.
Well, yeah, if it's not, so I mean, if it's out of the thermal enclosure, then you're venting it, right? So it's not, what we're saying is actually to make it part of this, it's no longer an attic. If you put the roof as the if you're bringing it into the thermal enclosure, it would be defined differently then at that point. Um, yeah, okay. I could look up. Um, it's a little bit, yeah, outside of my daily attention, but definitely important to look at. Um, any other questions? So, I mean, for a wall build up, yeah. Well, feel free to uh, reach out to me if you do have anything following this today, tomorrow, the next week. And uh, I should, before we transition, make a pitch for diving into the hands-on and construction details and getting into it from a building perspective from EMU Passive and the certified tradesperson course.
Yeah, Ken, unfortunately, Enrico from Emo Passive just messaged me that he had to step out, so I will just be filling in for him. But if you could go through the next
Yeah,
slide, please.
absolutely.
Yeah, but yeah, we'd like to promote this opportunity to get passive house tradesperson certified. And 3C Run is offering passive design build bootcamp from September 29th to October 3rd in Ventura, California. Next slide, please. So if you are a builder, an architect, or a construction professional, this course might be for you. And this training is completely free for those within the county of Santa Barbara, San Luis Obispo, and Ventura. And if you are outside the Tri-County region and still interested in this course, there's also an option to purchase this training. Next slide, please. There are two formats for the boot camp. One is in person and the other one is hybrid. For the in-person format, all 5 days will be in person with a building science course on the first 2 days, a hands-on workshop the next 2 days, and on the last day, there's the exam. And the deadline to apply for this format is on September 19th. And the other option is the hybrid format. Next slide, please. So instead of doing the building science course in person that first 2 days, you have the option to do it self-paced on demand. Then the hands-on workshop and the exam are in person for the next 3 days. The deadline to apply for this format is on September 1st. It's a little earlier so that you have enough time to do the building science course on demand on your own. And if you have any questions regarding this course, I will drop Enrico's email in the chat. And next slide, please. So as we wrap up, I will also be launching our survey. Please let us know your thoughts and what other improvements and courses we should offer in the future. So if there's a course or topic you're really interested and would like to know about, let us know in the survey. And if you have any, sorry. If you have any energy code or Cal Green questions, we have a code coach program to answer those questions for you. Next slide, please. And for any questions regarding your AIA units, please reach out to my email, which is on the slide right here. And in the next couple of days, you will receive an email with the slide deck and a link to the recording. And we currently have two options to get Passive House certified. The first one is what Ken mentioned in the beginning of the course, where you can get certified Passive House designer consultant. You can join the cohort, and this one starts in the fall, and as well as the boot camp, which I just went over. And we also have two upcoming Passive House network courses. One on August 12th, not Passive House, I'm sorry. Passive courses, Next Generation Passive House Solar in Santa Barbara in person. And on August 14th, there's an Intro to Passive House Trade, which I think you are the instructor, Ken, as well.
Could be, yes.
Yeah.
And for those interested in diving, yeah, even more into construction details and all of that, it will be very informative and fun class and discussion.
Yes, very excited for
Sure.
that as well. I'll see you there, Ken. I will be there. But yeah, you can sign up for these trainings on our website, and I will keep this open if anyone has any last minute lingering questions. And if you haven't filled out the survey, please do so. Thank you.
Thank you. It's good to be with you, and feel free to reach out again. And look forward to more high performance building out in your area.
I'm not seeing any additional questions in the chat, so um, if there are no additional questions, I'll go ahead and end the course. Thank you, everyone.
Great. Thank you, Danica.
Thank you.
Bye-bye.